Alright guys, so in this video we're going to be looking at part 2 of displaying data. So in the last section we looked at pictograph, dot plots, frequency tables, bar graphs, circle graphs. In this video and in this section we're going to be looking at more complex graphs, our line graphs, scatter plots, and then with the scatter plots our trend lines. So we're going to be kind of taking it further into later elementary school, maybe even early algebra, with these scatter plots and trend lines. Now, in this specific section, you will not have to draw any of these graphs so much as you'll have to be reading and interpreting the graphs. So we won't be drawing line graphs or plotting scatter plots necessarily. More or less, we'll be interpreting them, so answering questions about them. So with that being said, our first type of graph today is going to be line graphs. And so our line graphs are going to be different from our scatter plots in that there's going to be points, and the points are going to be connected by a line, versus our scatter plots are just going to be a whole bunch of points. So in our line graph, you've got an example of that one on the right. They have a title, they have X and Y axis labeled, and then of course you see those points on the graph, and then they are connected by a line. So example 1 says the following graph shows how the car value depreciates each year. This graph allows us to find the trade-in value. So I'm going to write that. Allows us to find the trade-in value for each of the 5 years. The percent given in the graph is based on the selling price of the new car. So example 1 says, what is the approximate trade-in value of a $12,000 car after 1 year? Well, the first thing I have to find is the percent of the selling price that is the trade-in value. That's what this y-axis tells me over here. So because I'm looking at 1 year, I'm going to follow that up to the graph and then come over. So 1 year to me looks to be about 70%. I have to estimate. So if you get a slightly different number, if you said that that was 75% or 65%, as long as your numbers are close to mine, they'll be marked correct on the test. But I'm going to say that that's about 70% of the selling price of the new car. That's what percent of selling price. Well, my selling price of my new car was $12,000. Now, I can't do 70% of my calculator. I have to convert that thing to a decimal. So if you remember our acronym DP, if you're going from percent to decimal, you're going to move it 2 decimal places to the left. And so that's going to give you a number of 0.70. All right, so I'm going to multiply those two, and I get out an answer of 8,400 is the trade-in value. The next question is slightly different. It says, how much has a $2,000 car, $20,000 car depreciated after 5 years? So now this one is asking about the depreciation, not necessarily the trade-in value. But we're going to have to use the trade-in value, and then we'll find the depreciation. So the first thing is I've got a $20,000 car. That's going to be my selling price. And then I'm selling it after 5 years. So I need to go to my graph where it says 5 years, follow that thing up, and then do your best to follow it over in a straight line. And I'm going to say that thing looks about 30%. You could maybe even say that it's 25%, but I'm going to go with that. That's 30% of the selling price. And so I'm looking for what is 30% of my selling price, 2,000. Well, just like before, I need to convert that thing to a decimal and then multiply. So that is going to give me a trade-in value of 6,000. Now, they did not ask me for the trade-in value, they asked me for the depreciation. Well, the depreciation would be the selling price, 20,000, minus the trade-in price. that difference is going to be the depreciation. And so my answer for this one is going to be $14,000 is how much that car depreciated over 5 years based on this graph. All right, then letter C says, what is the approximate trade-in value of a $20,000 car after 4 years? So I'm going to 4 years on the graph. Going to follow that thing across with my best attempt at a straight line. Looks to be about 35% because it's not quite 40. So 35% based on my graph. Well, just like before, I need to convert that thing to a decimal, 0.35 times my selling price, 20,000. When I multiply those, I'm going to get a trade-in value of $7,000. All right, and then the last one, Danny wants to trade in her car before it loses half its value. When should she do this? So what I'm looking for, half its value is going to be at 50%. And she wants to do that before it gets below 50%. So 50% is going to be about right here. I'm going to follow that thing over to my graph. Whoa. Follow that thing over, which is going to give me 2.2, 2.3 years. Probably 2.4 would be a better estimate since it's closer to halfway. So about 2.4 years. Because again, I went to 50% on my trade-in value, and then I just tried to follow that thing down to estimate. You could even make a case maybe that it was 2.3 versus 2.4. Like I said, as long as you're close, I'll give you credit because these you're just estimating on the graph. All right, example 2. This one I've got a double line graph. Also notice we've got this little break right here. That little symbol just means I'm jumping up and I'm starting at 125. I'm not going to start down here at 0, 50, 100. I'm going to skip all that and jump straight into 125. That's what that little broken symbol means. So the graph below shows the line graph for the participation in the NCAA sports for both men and women in the years down below. So here's the school years across the bottom, and then the participation. Highlight this part. This is the participation in thousands. So be very careful. That's not 225, but that number is really 225,000. So just be careful of that, especially in the homework and on the test. So participation in thousands, and then the top line is our men, and the bottom line is our women. So if your graph is in black and white, I would go ahead and label this that this is men and women, just so that you, when you look back at your notes, you see which is which. Letter A says, about how many more men than women participated in NCAA sports in 2004 to 2005? So for this first one, 2004 to 2005, I'm going to find that part on my graph. And then it says how many more. So I'm just going to subtract them. I'm going to do men, because they had more. Men minus the women. Well, it looks like men in 2004 had about 212, 210, somewhere in there. 1,000, right, because it's in thousands, minus the women had about 160, 162, somewhere in there. Okay, and so then when I subtract those, 212,000 minus 162,000, I'm going to get about 50,000 more men than women. Now, again, because I'm estimating, your numbers could have very well been different. As long as you are in that range of 50,000, that's why I have those little approximate bars. As long as you're in that range, I would count that correct. Now, if you're at like 750,000, obviously that is not anywhere close. But if you're close to that, we would be good to go. All right, letter B, between what years did the number of participants not change for both men and women? Meaning, between what years did the graph stay the same? Did it stay flat? So as I'm looking on this graph, I see here that it looks like the men didn't change and the women also didn't change. So during those years, did it not change? Means you're looking for a flat line. Well, my years are going to be 2000 to 2001 to 2001 to 2002. And so we could say between the years 2000 to 2002, the participation did not change between men and women. And then letter C, what seems to be the trend for both men and women in terms of, is it increasing, decreasing, not changing? And it looks like overall for men and women, both have had increased in participation. So you can write that in your own words. But overall, across from 1997 to 2005, when this graph ends, both of these are gradually going uphill. So they are increasing in participation.